Today we're going to do 8.3 and most of 8.4 notes. Acids versus bases. Acids produce the hydronium ion in solution, which is H3O+. The properties of acids are they taste sour, they react with metals, they're conductors, they're corrosive. Corrosive just means it kind of decays away. And they change color in the presence of an indicator. An indicator is any substance that changes in the presence of an acid or a base. And acids usually start with hydrogen. For example, hydrobromic acid is HBr. And acids are found in vinegar, aspirin, citrus fruits, soft drinks, fertilizers, and car batteries. Bases. Bases produce the hydroxide ion in solution, which is OH-. They taste bitter. Bitter is something like coffee or baker's chocolate is bitter. They feel slippery. They're conductors. They're corrosive. And they also change color in the presence of the indicator. So the last three properties are similar between acids and bases. They end with OH usually. For example, potassium hydroxide, which is KOH. Bases are found in deodorants, antacids, soaps, and fertilizers. Here's the pH scale. It ranges from 0 to 14. Your strong acids are 0 to 3. Your weak acids are 4 to 6. 7 is neutral, which means it's not an acid or a base. Weak bases are 8 to 11, and strong bases are 12 to 14. So you increase in basicity the higher the numbers, and then when you lower numbers, you're increasing acidity. The pH scale is a measure of the hydronium ion in solution. The greater the concentration of the hydronium ion, the lower the pH of the solution. Strong acids and bases. Strong acids ionize almost completely in water. So if you have a hydrochloric acid and you add in water, it's going to break up into the H3O+, which is how you know it's an acid, and the Cl-. But because it ionizes almost completely, that means it's going to have at the end mostly products. Bases dissociate almost completely in water. So when you add KOH, potassium hydroxide, to water, it's going to break up that KOH into its ions. And so at the end of the solute reaction, you have mostly products again, because they're doing it almost completely. Weak acids and bases. Weak acids ionize poorly in water. This CH3COOH is vinegar. The hydrogen is at the end instead of the front, the way that's written. And if you add water, it's still going to create that H3O+ ion. So for at the end, you're going to still have mostly reactants because it's going ionizing poorly. Weak bases dissociate poorly in water. I said most bases end in OH, but not all. NH3 is a base. That is actually ammonia, and you should know that that is a base. It's on the back of your periodic table as well. It's at the bottom. And if you add that to water, it makes NH4+ and the OH, which is why it is a base. But at the end, because it dissociates poorly, you're going to have mostly reactants. Buffers. Buffers are substances that react with acids and bases with little change in pH. For example, you have buffers in your blood because blood needs to stay at about a pH of about 7.3. If it doesn't, you have buffers so that it will stay that way. And if it doesn't, you will get sick. Electrolytes. Electrolytes are substances that ionize or dissociate when dissolved in water. Acids, bases, and salts are all good electrolytes. The stronger the acid or base, the better the electrolyte. Gatorade is a good electrolyte because it does have a salt in it. And when I talk about salt, I don't mean talking about table salt. We're talking about any kind of ionic compound. Electrolytes are beneficial for conducting electricity. Strength versus concentration. Strength refers to how well the acid ionizer or base dissociates. So if you have a strong acid and base, it ionizes almost or dissociates completely, which means you have mostly products. Whereas weak tells you it doesn't, so you have mostly reactants at the end. Concentration refers to how much of the acid or base is actually present in solution. There are two different things. For example, hydrochloric acid is a very, very strong acid because after you add it to water, you have mostly products. However, if you had only 1 drop of HCl in a 1 liter of water, it is not very concentrated.